working with Newton's law. Okay, so what we are going to do is, suppose we have different objects and different forces acting on it, then how we are going to apply F equal to ma, and we are going to find the acceleration. So what we are going to do is, we are going to solve F equal to ma. So till now you have solved only in one dimension, means if you are given a force, you just write the different forces and subtract or add them and find the acceleration. So but if you have, suppose, forces acting in different directions, so how we are going to do? So just follow these steps. So steps to solve the equations. The first step is, first identify the object. Identify the object. So identify the object means what? You have to just decide the object, on which object you are going to apply the Newton's law of motion, on which object you are going to apply the F equal to ma equation. So first we will identify the object, and while identifying the object, you can take combination of objects, or you can take single object. You can take single object, or you can take combinations of objects. So what is the rule for that? Which can be taken together, which cannot be taken together? If two objects have common acceleration, then they can be taken together, because see, in F equal to ma equation, if acceleration is not common, then what you should write for a? You have to write only, you should have only unique value of a. So for example, I am giving you an example. Suppose I have these two objects. If I pull this object here, then a and b will have common acceleration, so they can be taken together. So a and b can be taken together. But in another case, we can see, if you have a like this and b like this, and if you are pulling it, so b is going downward and a is going, suppose this is b, this is a is going rightward. So these two are not having same acceleration. So a, b and a are different. So a and a, b are different. So these two cannot be taken as one single object. Cannot be considered as one object, one system. Okay, but here this can be taken together, because these two are having common acceleration, since a equal to ab. So this can be taken together. So first task is to identify the object. Second is, now identify the forces. Identify forces. So what are the all forces that we have discussed? The forces will be either gravity. Gravity will be there on every object which is present in the system. Mass, having mass, that the gravity will be acting mg. Now we can take, if the object is in contact with some other object through a surface, then we can write normal and friction. If surfaces are smooth, then friction is will not be written, only normal will be written. And then we can have, if you have a spring, you will write a spring force, and you can also have some external forces, means type from where it is originating, that will not be given. You will only be given the forces coming from some external place. So I am giving you an example. So suppose, identify forces and make free body diagram. Make free body diagram. So what is free body diagram? So what is free body diagram? We represent the object, the whole object, as a point, and we show the forces with arrow mark. So I will give you an example. Suppose I am having an incline and an object is kept on it. So what are the different forces acting on? First, I will see what are the different forces. So suppose this inclination is theta. So first force is mg. Second force is, since it is in contact with the surface, there will be normal force. And if the surface is rough, the object is trying to slide down, there will be friction in upward direction. If the surface is smooth, only these two forces will be there. So let us assume smooth for simplicity. So if the surface is smooth, we will have only these two forces. So these are the two forces. And how do you make the free body diagram? You just consider the object as a point and draw different forces like this. This is normal and this is mg. And while writing this, while drawing the free body diagram and while representing the forces, it should be very much clear in what direction exactly this force is going. You should not, I have seen many students will do like this, just write with a very small sign, and it will not be clear that in which direction the force is actually. One will be like this, other will be like this, means it is not clear by looking at the diagram. But when you draw the diagram, it should be clearly understood from the diagram that in which direction the forces are acting. And from the upper surface, from the upper vertical, the normal will be making angle theta. Why? Because this is perpendicular to what? In this surface, perpendicular to this incline, and this incline is making angle theta with the horizontal. So this angle is going to be theta. So you have to represent like this. Similarly, I am giving another example. Suppose I am having a pendulum and this pendulum is moving. So suppose in this pendulum, the bob is at angle theta with respect to vertical. So what are the different forces? So here one force is mg, another force is the tension, and the bob is not in contact with any other object, so there will not be any normal force, and its free body diagram is like this: mg and tension. So in this way we will make the diagram, and this is also again theta. So what we are doing, first we identify the forces, then we write the we draw the FBD diagram. FBD, free body diagram in short, it is called FBD. So we will draw it like this. So FBD of pendulum and FBD of an object on the incline. Okay, another we can draw. We will take one more example. One object here, another object kept on it. So this is suppose A, this is B. So what will be free body diagram, forces, and then free body diagram for these two objects? So we will write separately. We can combine them together also, we can write separately also. Okay, so first we will see for object B. For object B, so what are the different forces on B? One is its weight. Suppose its mass is mb, its mass is ma. So first on B is its weight, mbg, and from the ground, since it is kept on surface of A, the A will exert a normal. Suppose this is called N1. So these are the two forces only acting on B. So the B free body diagram will be N1 and downward will be MB. So this is for B. Similarly for A, if you draw, for A, what are the different forces? For A, there is MAG downward, then normal from the ground, that is N2, and on from the upper surface there will be a downward normal, because for every force there is an equal and opposite reaction. So if A is exerting force N1 on B, the B will exert the equal force N1 on A. So there will be downward force N1 from the B on object A. So on object A, if you draw the diagram, we have MAG, this is MBG here, MAG downward, then we have N2 from the ground the upward normal, and from the object B we have another normal, that is called N1. So we can write for A like this. And since in this case in this case of two objects, the two objects are kept on the surface, so their acceleration can be taken 0. They have only one acceleration, that is 0. So they can also be considered combined. So for A and B together, combined system. For A and B, if you consider together, you have to consider the total mass, that will be MA plus MBG. This is the downward force. Now from the ground there will be normal, that is N2, and there is one more force, N1. So N1 is what? Internal force. N1 is what? Internal force between A and B. And if you write N1, this is what? N1 is appearing twice. One is on B and second is on A. So the N1 will get cancelled. So any internal forces is not written while writing free body diagram. While drawing free body diagram, you will not write internal forces. Why internal forces are not written? Because internal forces are going to get cancelled. You can see if you combine A and B here, then N1 is downward here on A and N1 is upward on B. So if you combine these two, this N1 is going to get cancelled. So that's why we do not write internal forces. So in this way, we draw the free body diagram. After this, what we are going to do is, after drawing the free body diagram, our next task is